This is question number 36 on the January 2017 Algebra 2 Regents. And what we have here is actually a pretty straightforward substitution, kind of a plug and chug question. So we have, using the formula below, determine the monthly payment, which we will see as PMT, on a 5-year car loan. So 5-year, that'll represent the number of monthly pay periods, but obviously 5 years would be 60 months. There are 12 months in a year. So n equals 60. With a monthly percentage rate of 0.625, that is our R. Now, again, we have to convert that because this is in percent, and we actually need it in 0.00625 decimal form. And again, we divide that by 100 to get it in non-percentage form. So 1, 2, and that's what we get. So that's going to be our I, and it has an original cost of $21,000 and a $1,000 down payment, which means that we are financing the present amount borrowed is going to be $20,000. That's $21,000 minus the $1,000 down payment. And here all we have to do is literally just fill in the information that we need. So Pn goes here, the I goes here, and here. And then up top is our negative n. Alright, so let's copy the formula in with our numbers in place. So the Pn is 20,000. The PMT is what we're trying to find. The question says determine the monthly payment. That's one variable. And we've got 1 minus 1 plus 0.00625. That's all raised to the negative 60th. And all of that is divided by 0.00625. So what we're trying to solve for here is the PMT, and again, let's just highlight this to make this somewhat consistent with what we're doing. This is my I, this is my I as well. This here is the number of pay periods, and again, there is a negative up here. This is our Pn, and that's that. So now what we want to do is probably get this value in the parentheses. These are all numbers, so we can actually just get that value. So we have as 1 minus, this is 1.00625 to the negative 60th, divided by 0.00625. So let's get that value here. We've got 1.00625 raised to the negative 60th. That's just this component here. We've got 1 minus that. Okay, and then we're going to divide that by 0.00625. Got 49.90. Okay, or 49.905 if we want to be a little bit more precise. So 49.905, that's the value we're going to copy here. So this here is 49.905. So then we can just rewrite what's left of this equation. That's 20,000 is PMT times 49.905. And then all we're going to do is divide both sides by 49.905 to get our PMT. And again, I've mentioned this before, but depending on the particular model of this calculator that you have and the particular software you have in it, you may actually be able to do that entire fraction in one sitting here. There's a mode in alpha y equals that allows you to input fractions. If you have that, obviously use it. The emulator that I'm using here does not have that updated software in it. So what we got is $400.76. And the question is to the nearest cent. So if we look here, it's 0.758. We're obviously going to round that up. Now there is a second part to this problem, which is that the affordable monthly payment is $300 for that same time period. So that's what we want to pay. And the question now is determine an appropriate down payment. So the down payment is the cost of the car minus what we're going to finance. That's our down payment. So in this case, we made a $1,000 down payment. Okay, and the cost of the car is $21,000. So the cost of what we're going to finance, that's going to be $20,000. So basically what we want to do is figure out the entire cost of our financing, the present amount being borrowed. So now this is just going to be Pn equals PMT, 1 minus 1 plus I to the negative n all over I. You can see I just copied that equation from there. And let's fill in all of our information. Now realize that this time we're given the payment, right? And we assume that the interest is still the same and that the number of months remains the same, but this time we're actually trying to solve for Pn, because that will tell us how much we can afford to finance and what the down payment should be accordingly. So Pn is equivalent to 300 times 1 minus 1 plus I to the negative, well, let's actually fill that all in one spot here. 1 plus I, which is 1 plus 0.00625 to the negative 60th. All of that over 0.00625. And we already found this value. This is 49.905 from over here. None of those values have changed. So our Pn is 300 times 49.905. And we got is 14,971 and a half. Okay, so how much do we want to put down? Well, if this is what we can afford to borrow based on the $300 monthly, the cost of the car is $21,000. And what we want to finance is 14,971.5. Well, the difference there is going to be 6,028 and a half. And it says to the nearest dollar. I would say that 6,029 is what they're looking for here. If we actually look at the calculator, I mean, if we were to multiply by that entire thing, it would really be 14,971.5 something. The number would be a little bit higher. So then this would actually be $1 lower. I don't believe that the Regents is going to make a big deal out of whether this answer is 6,028 or 6,029, just because some of that is going to be attributable to rounding. So there's that. This is not a question that requires a tremendous amount of thought. This is much more of just fill it in and make sure we do the algebra correctly and work the numbers in correctly kind of question.